Good afternoon. Good to be here again this year. So today I'll be talking about profiling neural audio plugins. So let's get started. So in essence, what is profiling? So the general idea is that anytime you have some program, you would like to know, how well it performs and what are the bottlenecks that's there, so that you can try and improve the performance. So and anytime so again, the difference between profiling and then benchmarking is that benchmarking is something you do when either, let's say, you have some an algorithm section, you want to see how well it performs with some other algorithm. There's some comparison also between your old version with the new version. But again, profiling is more to do with trying and finding, is there any possible hotspots which you could try and improve. So as it says, benchmark is measured to know your application, while profiling is measured to improve your application. And again, one important thing, which anytime you do some profiling, what you need to do is that you always need to profile in the release build, mainly because of the fact that with debug builds, you wouldn't really have any optimization that's done. And also with release build, it strips away all the debug symbols and stuff. So and also another thing to note is that anytime you build something, always try and include an debug symbol file with it. Otherwise, when you want to see the call stack and stuff, if you don't have, if it doesn't have the symbol files, it can't really map to the actual memory address with the names of the functions and stuff like that. Another small reminder is anytime you do profiling, just make sure that premature optimization can be costly. So make sure that you don't go deep into it. Just try to get some minute performances and stuff like that. Ideally, you build you build your application, and then you do profiling as you go along to see whether is there any major bottleneck, and if there is something, you try and improve that. And why would we want to profile neural audio plugins? One of the main reasons is that currently, audio plugins are predominantly CPU dependent. Even though there's been explosion of machine learning and things like that, still the DAW ecosystem hasn't really changed. Anytime, even if, like, let's say you're a researcher, you built a nice let's say a morphing model or something, and you want to bring it to the creators, then the only way you can do is make that as a plugin which has to run in real time, in a sense. Take a small buffer, process it, sends it back. So, and again, even though there are companies like GPU Audio working on trying to bring GPU processing into it, we are still mostly reliant on CPU. So performance is very much a key factor here. And also, DAWs host multiple plugins. Generally, when you have researchers publish their results and stuff, they focus on just real-time factor of one inference. But let's say in a big project, when you have like hundreds of tracks, and sometimes your plugin can be in series, so everything has to process within that hard deadline. And also, neural network-based plugins need to be highly efficient for all these reasons. So profiling is a really important tool to help identify places where we can improve. So in general, we have two broad categories of profiling. One would be sampling based, and one would be instrumentation based. Sampling based is pretty simple. The idea is that in a predefined interval, just like how you have sampling with audio, what you do is the program, the operating system, what it does is it goes takes a snapshot of the call stack of your particular process you're trying to profile. So let's say it has multiple threads. It's going to take a snapshot of all the different threads. So in essence, you'll have a snapshot of the call stack, a program counter, registers, and stuff like that. And then it just records it, and then later on you could view that. So it's less overhead. You don't do any function calls and stuff like that. Even though there's small bit of time it takes for snapshots, it's pretty low overhead. And disadvantages with that is that sometimes you could miss infrequent bottlenecks. Again, we'll come back to specifically how sampling works and stuff. And then the instrumentation technique is where you explicitly add some code into your program, and so that anytime that particular code hits, records something, whatever you're trying to record. And also, you could also have, event-based recording where, like, let's say, sometimes like, let's say a cache hit happens or a certain number of cycle happens and stuff like that. The disadvantage with that is, again, the advantage with that is that it's a bit much more detailed, because anytime you have, if you want to know exactly how long a particular function get called or something like that, you would be using instrumentation. Again, we'll look at that in a minute. And the disadvantage with that is that it has a high overhead, because since there might be some function calls every time that particular point hits in your code. So those two would be the broad category. Again, with the different type of profilings, you have something called a time profiling. It measures how long functions take to execute. In essence, it'll tell you, okay, these are all the function calls that happen, and these are all the time it generally took, not a particular function. And then it's generally sample based, and you have something called system trace, where you capture pretty much all system-wide information like CPU cycles, memory allocation, thread interrupts, and stuff. And then you also have something called performance counters, which track specific hardware events. You could see cache misses, branch predictions misses, and stuff like that. So since I pretty much use Mac, the profiling tool I use is Xcode. You do have other tools, Xcode Instruments, sorry. You do have other type of profiling tools available for Windows and Linux. So the advantage with Instruments is that it's pretty much it's well integrated with Xcode, so you could develop at the same time profile as you go along. And also it has nice visualization features. You could see the call stack, timelines, and everything. We'll look at that in a minute. And also analyze traces alongside timing data. So it has a nice user interface, so that really helps us viewing things. So before I go with that, let's quickly look at how we do time profiling. Again, so this is how instrument looks. So you have different instruments is the name of the app. You also have different instruments which you could select. You have a whole bunch of different type of profiling you could do with that. So in here I have just a bunch of ones. The main thing we will be looking at are audio client, CPU counters, time profiler, and OS signpost. So let's say in this particular example, I have used RT-Neural. It is an a library for real-time neural network inference. Specifically, you could use that for audio. It's real-time safe. So in this case, I have two simple example models. One is a bit small, and another one is a slightly larger model. So in here, if we just go to time profiling, what we could see is that, so you get this, a detailed view at the bottom, and also you could have this track view. So if I zoom out, so in essence, you could see that I have ran the whole profiling for 20 seconds. So this is what the whole CPU usage is in that particular track. The advantage with that is that you could, like let's say I'm in the time profiler track. So I could choose different ways I want to see the call tree. So let's say in this case, I'm going to separate it by threads, and I'm going to hide all the system libraries. So you have these two views. One is called a call tree, and another one is called a flame graph. So in here, the one thing we are, so when I profiled it, I ran the plugin in a simple audio plugin host that comes with Juice. So here you could, the one thing we are looking for is the audio thread. So not this one. So I could expand. Sorry, I think it's the other one, I guess. Missing something there. All right. Okay. Can't really get that one exactly out. Anyway, I'll come back to that in a second. The idea is that you can view all the, maybe I'll try in this one. Time profiler. Yeah, so I could see that. So this gives the whole call stack. So pretty much the HALC is the hardware layer abstraction controller thread. So this is where your real-time processing happens. And you could see that in here is where the process block gets called. So if I want to isolate that, I could see that. And it tells me within these, call stack, it tells you the whole process block in that 20 seconds, it ran for 15 seconds of CPU time. And in that, each of these particular blocks ran for a certain number of times. So more than the call tree view, the flame graph is a bit more ideal to see what gets called and how much time something got spent there. So what the main advantage with this is that if you have a code block and let's say you have a piece of your main forward function that process the neural network, you could pretty much see which section or which function within that takes what amount of time in the overall context, right? It doesn't tell you how exactly or the exact timing of each function call, but it tells you in overall time how much each one contributes to. So it gives you a general idea, but we'll look into instrumentation. That'll tell you a bit more detailed view. So let me go back to the slides. Yeah, so the next one is called instrumentation, as we looked at earlier. So the main advantage with instrumentation is that you could, let's say you have a function and you want to exactly time how long it took for that particular function to get executed. So then you could use, instrumentation. So in Mac OS, you have something called signpost. It comes with the OS log. So you could add that to your code. So in this case, you need to explicitly add, certain macros at points where you want to profile. So, and the advantage with this is it is very precise. It exactly tells you in microseconds and milliseconds how long something ran. Again, signpost is not that much. It doesn't have a lot of overhead. It's kernel level. So, it's really handy to do things. The disadvantage is that you need to manually add them into the code. So it's more helpful with development. But let's say you have a compiled binary somebody else wrote, then you can't really use that in that case. So to see that as an example, I have added the signpost in the process block. So in here I could see that. So with RT Neural, you have these two versions. You have this compile time version and also runtime version. So these two tells me where it happens. So I could also choose a certain portion, and let's say if I want to see what happened there, I could take them based on, let's say, let me select that, and then in this case I could see the average time it took for each of those functions, function calls. And also you could see that, what's the max time it took. There's not much of a deviation here. So it means that pretty much every time the process block was executing that, neural network code, it has consistently been running at an average of 1.2 milliseconds. But when you have this larger code, and if I again see what happens there, in this particular example, I could also see, you could see that even though the average time is between, for the runtime block, it's 8.2, but sometimes the maximum duration has reached 16, right? So this is it tells you that it's not efficient all the time. Again, in real-time audio programming, the one thing you focus on is the worst case performance. So this helps you identify how much something takes and what's the maximum duration that happened and stuff like that. Again, you could go in depth into it. You could also see where exactly that happened and things like that. I'm just brushing over things here. So that would be your instrumentation. Then the next thing is you could also since we saw earlier, we have something called instrument counters. So the advantage with that is that you could look at things like cache misses and stuff like that. So modern CPU relies heavy much on fast caches. So you have this two type of localities. One is spatial and one is temporal. So with spatial, the idea is that Anytime there is this, the computer goes and fetches some chunk of data from the RAM. It doesn't take the exact piece of data it wants. It takes a larger chunk. The assumption is that if you're accessing something, you probably will be accessing something close by soon. So that would be your spatial locality. And temporal locality is that if you access something recently, there's a high chance that you might access that again. So yeah, so the idea is that you try and you could use for example, quickly, if you look at the instrument counter, it tells you how much cache misses happened. In this case, I have L1 cache and also branch misprediction. So you could again see that using your for particular threads and stuff like that. So again, things to keep in mind is that anytime you do some type of let's say you're managing your tensors and stuff like that, you focus on data-oriented approach. In a sense, you do structure of arrays over arrays of structures, so that memory is all in a contiguous block, so that anytime there is prefetching, it's cache friendly. So finally, you have this different type of inference engines that's available right now. So the main one is the Anira is a pretty new one. I think it came a few months back. So the advantage with that is that you could use different backends. You could use Onyx runtime. You could use libtorch. So again, it works on a separate thread. It doesn't run that on the audio thread. With RT-Neural, everything works on the audio thread, but the problem is that it's a pretty doesn't support all operations or layers. So and finally, anytime somebody really want to produce a professional production grade neural network based plugins, personally I feel that the custom inference code is the best way, rather than relying on other methods. So in that particular case, then you would really be you should be taking advantage of profiling, because there's going to be a lot of places where you want to specifically say whether a particular layer, like let's say you're using RT-Neural, you could use RT-Neural for particular layers, and then you could write your own code for your custom layers and stuff like that. So in that case, again, profiling really comes in handy. So that's pretty much it. Yeah, thanks.
Yeah, let's take some questions. Thank you so much for that talk. Carrying over actually from your last year's talk, have you worked with, for example, using quantization and like these techniques, pruning, and then comparing the and doing profiling basically and seeing what works best?
Not really. Pretty much whatever I have done so far is, I use profiling even before you start training, mainly because of the fact that, you have an estimation of what type of model size. You don't really need a trained model. All you need is just some random weights, and you could profile it and see whether can this, survive, or, what's the worst case performance of that, so that can it run in real time. So then you have an estimation of, okay, this is the largest I can go with, model size in terms of number of channels or in terms of layer size. And then you further start doing training. Then you do quantization or pruning that way.
I see.
So
because if you run
it still, you could do that with mainly with quantization. It helps with to at least profile and see, do you get any advantages with any particular chunks. But again, that would be more of benchmarking, as I said earlier.
Okay.
Comparing. Okay, this is my pruned model, and this is my pruned model. How much of an advantage I get, rather than particularly looking at any bottlenecks and stuff like that.
Got it.
Yeah.
And if I was interested in, for example, comparing to inference engines like Anira and RT-Neural, would profiling be useful there, or would that be benchmarking?
That again, that's more of a benchmark if you're comparing the whole thing. But as I said, if you're working with some RT-Neural based stuff, and a particular block is taking more time, or a particular layer is taking more time, then you could, or like let's say you're using different backends. XMD, or you're trying to take advantage of Egan or something like that, then you could compare it based on for example, that would be in one thing. And also, if you're using Anira, again with Anira, like let's say you're using Onyx, then that has different execution provider. You could have Core ML there. then that could use, if it's a Mac, then you could use the neural engine and stuff like that.
Okay.
So yeah, for anything that's just a section, then you could use profiling. Yeah.
Cool. Thank you so much.
Any other questions? Okay, so I have a question about, so like say for somebody who's just starting out and who wants to like take the Xcode project and start profiling. So is instrumentation app is part of the Xcode
Yeah, it's
thing
part
itself?
of Xcode, yeah.
Right. So,
So just when you, just like how you have build, you just have another option where you could profile it. So it automatically, compiles your code and then opens it in Instruments, and then it runs in there, and then you could just profile it.
right.
So the only tricky part is that, you need to, since it's all you're developing, VST plugins or AU plugins, then it needs a host to run. So the problem is sometimes, the host has to recognize the updated one. So there's a bit of things there, but still it's pretty, like let's say you're working on a standalone application, then it's all straightforward.
And like, do you also have like some suggestions on any resource material for anyone who wants to learn more on this?
No.
Except for the documentation available online. Is there like a...
To be honest, specifically with instruments, there's not much of documentation available, and even the ones that are available are more focused on Swift for iOS development or specifically for iOS apps, where to see whether there is any hang or lag or things like that. So, but again, yeah, you would be mostly looking at that. But I think like it's pretty intuitive in a sense. If you look at the UI, it's not much there. It's just that you just need to know what you're looking for and what you're seeing. So it should be pretty simple. And I think the one thing I always find it in juice forums and stuff like that is that anytime somebody asks a question, some veteran says that just profile it first. So people should be profiling a lot. So that's the idea.
Okay. All right. Thank you so much. Any other questions? If not, yeah, please round of applause for... All right.